Here we have a velocity and acceleration type problem about this dude swimming, and it gives us the velocity function. So I entered that into my calculator and find the times at which he changes direction. So we should know something changes direction where the velocity changes sign. So that's why I just jotted down right away where the velocity change sign. That's where we're going to change direction there. And so I have that velocity function in my calculator. And when you can look at the graph, you can let it calculate that zero right there to get that this t is equal to 56. And then we also have proper reasoning. We have to mention it changes direction. Just because your velocity is equal to zero doesn't mean it changes direction. The velocity must change sign from either positive to negative or negative to positive. So the velocity function must go from above to below or below to above the x-axis right there. So I graphed it, found it, and then stressed change direction at t equals 56 because the velocity changed sign right there, going from positive to negative. So there's part A. Part B says find the acceleration. So if they give me the velocity, I want to find the acceleration. We know the order goes position, velocity, acceleration. So I need to take the derivative of that at t equals 60. This is a calculator problem. So you're going to use the math 8 function with that, and then it does that for you and gets you that number there. And you know the acceleration units on there are going to be that. And then anytime it's asking is something speeding up or slowing down, you need to get the sign plus or minus. You need to figure out what the signs are for the acceleration and the velocity. Remember, if the velocity and acceleration have the same sign, they're speeding. The excuse me. So it's going to be speeding up if velocity acceleration have the same sign, and decrease the speed is decreasing if velocity acceleration have opposite signs right there. So we figured out what the acceleration was for using the math 8. I then took the 60, plugged it in there. I already had it in my calculator, so I just used the trace button and typed in the 60. And then you get the velocity is equal to that. So since acceleration and velocity have the same sign, that means your speed is increasing. Stephen is speeding up since the velocity and acceleration have the same sign. So make sure you get that proper justification down. Letter C says, find the distance between Stephen's position at t equals 20 and t equals 80. So if this is velocity, if I want to go back to position, I need to integrate the velocity. So I just integrated the velocity from t equals 20 to t equals 80, and it did the math 9 with that function in there. And again, it was already in there. So if you use that alpha trace button, it should be able to highlight that for you, where you don't have to type it in every single time there. But please practice this in the calculator all by yourself to get comfortable with that and get the speed going with that. And let me know if you're having any issues kind of getting those correct numbers. And we round all the decimals to three decimal places there. So there we go. And then part D says find the total distance that Stephen swims over that interval there. So that's a total distance traveled problem. And in your blue packet there, the total distance traveled is the integral of the absolute value of velocity right there. All right. So that's what we got to do. So you use the math 9, plug that into the calculator, and please let me know if you have any issues. If you forgot how to do that in the calculator, rewatch that calculator video where I showed you how to do all that stuff, or let me know if I can help you out individually with that. Pineapple.